Good morning, everyone. Good morning. Welcome back. For the survivors, for the ones that actually made the second day. That was actually awesome on the demo they're doing today. So we have been using a lot what they're sharing, and some of this is running in production. So day 2, my name is Carlos. For the ones that were here yesterday, we talked about renewals on the building agents. Today, we're going to talk about how we went and built the observability and the testing for that. Just one observation. In addition to myself, you have Vince, Aman, John, and Thomas on our booth out there. A lot of people came to understand the details. There is so much I can pack in 20 minutes. Over there, we have all the workflows, how we did the planner yesterday, and all the coding for this, so if you want to check it out. So with that said, I'm going to, for the benefit for the ones that will watch this later over YouTube, to explain what customer success is in a minute, and then deep dive on what is the teammate for the renewals that we did yesterday, what the observability and the testing looks like, and then goes for support. Support at Cisco is an interesting beast. We have an average of 16 million interactions a year, and the amount of tickets and cases last year was 1.6 million. This year is 1.4. So we increased a lot of the deflections, and thanks for some of the systems that we're going to show you. And also, we are more proactive to the customers. But think about Cisco, we have network and security, so when they have a network outage, people really get pissed off. And there is a lot of things that doesn't work, pretty much everything, if the network is down. So when you have those cases, we have sometimes catastrophic outages that get business down. So how we deal with that, and how I use agents for that. So in a nutshell, we have customer experiences, same methodology in the industry, land, adopt, expand, and renew, which is go for the teams that we have. Cisco customer experience around a 19,000 people organization. We talk about renewals team yesterday, and the teammate that now on agentic fashion belongs to that team. We're going to also cover technical support today. So with that said, the renewals teammate we mentioned yesterday, we evolved from the initial agentic foundations that we built last year. There was more about how we earn the trust and how we get an interface and a chatbot, to now have running in production a workflow-based approach when you bring the notion of delegation with the agentic teammate can be part of the team and has authority to do some of that, and you have the proof value of this. So that was yesterday. For the ones that are watching on YouTube, I recommend you to just watch the YouTube video from the yesterday session. But the questions of today is, how did we close the loop between the production feedback that is running at scale and make this as code for fixing using AI agents for that? How we observe on the case of support and actually build a semantic routing, because I run around 10,000 cases at the same time, so there is no way a man is going to be able to fix all of this at the same time. And how observability can become your enabler, but also your bottleneck if you don't watch it carefully. So let's go for that. So from yesterday, we learned that, hey, we built a very nice chatbot interface, 95+% accuracy, multi-step agency, all the deterministic RBAC, all the things that were right. And then I told you that people plateau on utilization. They ghost us at some time. So I explained to you how part of this was optionality that we give them, and then we remove with the forced curiosity kind of thing. And another one was build teammate that was more autonomy and give them more personalized and more ability to automate. So we went from low usage to usage climbing up, which then means we have an avalanche of feedback now. Right? Good problem to have. So everything is now a signal, not a noise. When I put out there and there is a thumbs down or a feedback, this is a signal. It's not something I can ignore, because otherwise what cleans up as adoption is going to clean up as feedback. Those idiots don't know what they're doing. Right? So every thumbs up is a lead. Every trace with an error is a potential regression. And every confused user is a description of a plan that needs to be addressed. Think about it. The human becomes the bottleneck, because the same agentic team that built that for the teammate cannot scale for thousands of thumbs down or thumbs up at the same time, which means that triage becomes very important, clustering some things, understand what's false negative, false positives, and all of this. And last but not least, the real question is, what is the shortest path for me to get a user's thumbs down as a feedback or a comment to actually become a merged PR, a pull request, without losing the quality and having the human oversight. Right? Let it think for a second. Your success on observability is proportional on how much crap you're going to need to deal with here. I know it's early in the morning, but we need all to wake up. Okay, let's keep going. So how we build that? We actually create not a ticket queue system. We went for a continuous feedback loop when we use the production signals and the flow of it, particularly with LangChain, directly into code change, with AI doing the heavy lifting and human in the loops where it matters. So here's how we approach the problem. First thing, we actually build an agent to capture the signals. So all thumbs down, all the errors, all the low confidence classifications, everything, we have production traces that we capture via LangSmith, and then we build a triage agent. What the triage agent is basically a deep agent that runs on a cron. It leverages LangSmith MCP and Jira MCP, and does analysis and diagnostic of the code, and has the ability to open the Jiras. Let me give you one comment. I compliment Ankush and his team on the LangSmith, because LangSmith MCP is absolutely awesome. It's not like an API that people put fast API and then call this an MCP, and then the crap API you have, the crappiest the MCP interface becomes, and then the AI gets all confused because of that. LangSmith MCP is really, really good. I recommend you to use. So you leverage this, and everything becomes part of the triage agent, which then feeds a coding agent. Realize that we have them to two separate tasks. I will explain you why in a second. And the code agent does the deeper diagnostics. It analyzes what the fixes would be. It clusters similar signals to belong to the same domain. I don't want to open 50 Jiras for the same potential bug, right? If I can cluster them and have one. So it does all the failing traces analysis, and then the review, we have the human in the loop. The human approves, the human goes redirects at any step. The human is responsible to PR as it relates to writing. Everything that is reading is done by AI agents. And then last but not least, we merge the PR and we ship to fix to the code. And that fix is a new eval on itself. So you don't call like, hey, we're having the day, we fix it, nice, pat on the back, move on. No, it feeds itself as part of the eval ecosystem. And we look at this from two angles, a proactive and a reactive. The proactive is what I have on that bottom side, which is turnkey evals. Before we ship any agent, we have the data subject matter experts. And by the way, I didn't build this material together with Harrison's team, but you can see a lot of analysis on what they said before. We have this implemented in production at scale already. So we have the data SMEs that validated the routing, use the LangGraph routing, as I mentioned yesterday, create the regression tasks, ship them safely, which we are trying to prevent issues before they can potentially happen. But then, when you have this running in production, the customer may say, hey, that answer is not to my like, it doesn't have on the accuracy, it doesn't fit, so they have a feedback, thumbs down, there is an error or a feedback, so we need to deal with that. That's where triage agent and the code agents come in, and after an agent ships, the real feedback gets triaged, and we address this. So this is the methodology that we use. It runs in production at scale, which is the key for us. I don't know how many users are going to use at a given time, and my team is very small. So there is no way I'm ever going to counterbalance on a human approach. Let's go a little bit to the triage agents. So I get a thumbs down as an example of people giving feedback. And that thumbs down can be just a thumbs down as a signal, or with a comment saying, hey, I don't like it, it's inaccurate, it doesn't serve my purpose, it doesn't align my business, whatever that is. So we fetch that trace, we read the code that actually maps to that trace, we put this on a classifier, and you either dismiss or go to the Jira. So what does it do? In production, it pulls the traces from the LangSmith on the next X amount of hours. We can define what X amount of hours are, and then it filters the thumbs down errors or low confidence routing and reads the related code that is trying to understand what the agent was trying to do at that given time for that particular set of traces. What I mean by set of traces, because you have the agent clustering the ones that are similar, because we don't want to, first, open a bunch of them that could be correlated. Second, we need to decide whether this is false positive or not. The guy may be on a bad day, or is a person that doesn't understand on that answer, or maybe it was an authentication error, and that person shouldn't even be on that environment, which is still something we need to trace, and we only open a Jira when there is something to fix. And how it is built, as I said, we use the LangChain deep agent library for the harness, and a structured system prompts that goes for what is the boundaries, what are the tools, the heuristics for the triage, and we decompose those triages into explicit steps with sub-agents that goes from coding and actually find the duplication on the cluster. It's important. I'm talking about thousands at the same time. We need an agent that actually correlates them and say, hey, you're dealing with 3 problems, 10 problems, not 1,000 problems. If you have 1,000 Jiras, the whole thing gets out of control very quickly. And LangSmith MCP we use for traces, Jira MCP uses for issues creation. So we have separation of state and church very clearly. So think like that, because if you start to mix domains, the context starts to get messed up, and the AI that's helping you lose context about this and lose the boundaries. And every action is traced, including the triage itself. So it traces itself, so it traces what the trace is doing, and the same thing, and you see more of that behavior. What made it work? There are 4 things that are worth to highlight. First, please, 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 if you want to get this in production at scale, treat evals like tests, not like experiments. Let me repeat it again. Treat evals like actual tests as part of the pipeline, not experiments. Evals live in the repo, not in CI, not on the black merges, not on the PowerPoint that you share to your boss, none of that. Do component level analysis and end-to-end analysis as well for the tribe, both. Not, hey, I did on a component, it looks good, and end-to-end, it looks bad. Data sets are versioning inside the code, not on the dashboard. Dashboard is for the bosses to look. The agents don't care about dashboards. I'm making fun, but you realize what I'm trying to say because it's very realistic in the real life. MCP is our integration layer. Agents talk to LangSmith, to Jira, to Git, and runs the eval running through MCP. It matches what Harrison just said before. We just have it running in production for some time already. Swap the back end without touching the event is only possible if you use MCP as the layer interface. It gives you that decoupling flexibility for you to play with. The same MCP tools now become what powers your UI, powers the IDE chat. You saw on the demo the fleet before, the triage agent, so on and so forth. And last but not least, as I mentioned before, human in the loop only on writes, not on reads. Everything like reads tracings, opening Jiras, the drafting the pull request, all of that is autonomous. What I mean autonomous means autonomous for you. You give authority for the AI to do that. You set the boundaries. Everything that is right, the human is on the loop. So the goal is to leverage, not to replace. So some lessons learned. Observability is your new bottleneck. If you're going to ship agents, and you're going to ship them at scale, look at my smile, observability is going to be your trouble. Just embrace it. Second, close the loop with agents. So you have the feedback, and you want to fix it. In between, you can have triage, you can have diagnose, you can have PR. Use the agents to help you do the work along the way. Keep humans only for the decisions. Don't fall to the trap that if humans orchestration-based DNA kind of system, it's not going to scale. When you get successful and you get adoption, that's where you get feedback. You want that. And if you become a bottleneck on your feedback, your adoption is going to fall. Third, evals are part of the infrastructure, not a side project. Every fix that we do generates a new test. Obviously, if you think that way, the suite compounds, right? And regression becomes permanent thing. It's not an exception. And as you think about using agents for this, shift the agent authority left, which means the data subject matter experts which aligns to the demo that was done before, ship agents with the routing guarantees, which means the subject matter experts on a particular domain, on my case, renews, on your case, is going to be whatever runs on your business, they know better what the steps should be. The coding guys that are doing the agents and the PR have no clue. So the subject matter experts is the ones that defines the routing that is embedded on the system, that has the most MCP-driven workflows, and the interface with the IDE shots, as was demoed before as well. So that was for renewals. Let me brief myself because I was fasting like there was no tomorrow. Let's go for the support. So in the support, we have a very interesting thing. Every customer of Cisco that has a support contract to open a ticket has automatically access of all that I'm going to show you. This is actually an anonymized scenario that we ran last week. This is a network or a customer, an enterprise, and it has footprints around the globe. So we went and did an analysis on all the potential configuration assessment of every device on their network. It looks big, but it's not. Think about this. This is a very small network for our standards, because if you think about a store may have 2 devices to connectivity, 3 access points. This venue has a lot more than this. So if you think about that, 5, 7 devices, 113, I'm talking about 15 branches. It's not a bad big. For being an international, it could be a clothing company, could be a restaurant, could be a bank, could be whatever. So, but we have 2,176 security potential findings. Every one of you, if you look up your hands, you have 10 fingers, right? Usually. Some of them may be fat. You have heard about the fat fingering configuration stuff? We got that a lot. A lot. So what we did an assessment, this is one customer configuration assessment. This is real. I just got to remove the name and the configurations of the customers. So you have this running. Then the question is, hey, where do I even start? What the heck should I do here? So we then provide to the customer this, which is part of the support analysis that they have an assessment. So we say, hey, out of this environment that you have some positive stuff. We have this product line that is actually compliant and secure, but you have some areas that you should actually look at it. So what happened? We already went through the whole configuration environment for the customer globally. We already use the AI to analyze against what the best practices are. We already find out potential vulnerabilities that exist. We already have the surface of attack exposure for that customer. Say, hey, dude, here is your environment. Then we have an AI system. We explain to the guy, hey, we can help you. And the feedback for the gentleman or the lady is, what should I focus first? So think about it. There is no configuration, there is no assessment, there is no mitigation, none of those words that give you a clue. The customer just said, what should I focus first? This is like as vague as it can get. It's like marriage. Your wife comes to you and said, do I look good to get out? You do me if you say yes, you do me if you say no. If you say yes, you are a monster because yesterday you said that I'm not pretty enough. If you say no, you're a monster now. So it's like here, this is a very high-level context. I have some that people say, so, and, help. So for an AI agent, if you receive a word telling help, what do? Right? So we realize that behind the scenes, you already have over 350 potential high critical severity stuff that is going to hit this customer. So we use the context of the customer at the real time, plus the best practice, plus the historical, plus the fat fingers, plus all the customer cases and tickets that were open before, and you surface the most likely scenario that will impact him or her. How do we do that? We build a semantic routing. So the semantic router, what it does, it's actually defined based on context which specialized agent would be hit given a scenario that you don't have enough context on the prompt. It's exactly the opposite that we had yesterday. Yesterday, I had a very detailed prompt that I need to create planner which are hierarchical. Here, I don't have enough context from the prompt. So I need to actually have the contextualized from the real-time environment plus the historical to define how I route
across specialized agents. So I have agents for configuration, for security, for troubleshooting, for assets, for inventory, all of that. Who am I going to hit? And we run this in parallel pipeline, and it must run in parallel with the guardrails. Let me explain why. Here, I'm actually on a proactive fashion. I'm sharing with the customer what may happen before. There are some situations that we are on the middle of the fire and the outage, and people get really heated. So you're son of something, and then the model comes back and say, I don't believe that the genealogical lineage of the engineer would help solve that problem. And I'm looking at the model like, dude, it's cursing us. Do you understand that? So, but you need to get guardrails before that because it contaminates the routing. And you have semantic routing, you remove this, and semantic routing goes and define what agents. But we, again, every step is traced. So you go through the guarding rails, the agent selection, execution, through the LangSmith. So the current state feeds the routing on how you do semantic approach, and every agent, every specific specialized agent has a data set, and as we start to learn, the router now gets updated and what the context exists in order to actually get on the routing. So this happens automatically. You have this done on multi-thousands at the same time, because I cannot be judging what the AI is going to argue back. It needs to be done at scale. So we have this running, and the paths are being regressed, and we have human-driven recommendations that are gold priority, and the ones that are learned and silver, and we run this with LangSmith over and over again in loop, real time, as the system self-learns itself. And last but not least, we observe the observer. Because LangSmith becomes super critical for our business, so we actually feed this as infrastructure, and you observe, you leverage Splunk to observe how it's doing. So you give an idea. We have 153K requests concurrently at the time that I was just taking those screenshots, which are very slow latency, and 100% SLO accomplished. With that said, hopefully it helped you as you embark on your agentic workflow. We are all there on the booth. Thank you very, very much.